Hello students, here question is given X and Y are two volatile liquids with molecular weights of 10 gram per mole and 40 gram per mole respectively. Two cotton plug, one soaked in X and the other soaked in Y, are simultaneously placed at the ends of a tube of length L equal to 24 centimeter as shown in the figure. The tube is filled with an inert gas at 1 atm pressure and a temperature of 300 Kelvin. Vapors of X and Y react to form a product which is first absorbed at a distance d centimeter from the plug soaked in X. Okay, take X and Y to have equal molecular diameters and assume ideal behavior for the inert gas and two vapors. Okay, this is the tube. Here cross sectional area of this tube, is A. Okay, this tube is A, and here the value of D in centimeter, shown in figure as estimated from Graham's law is, okay. According to the Graham's law, rate of diffusion of X upon rate of diffusion of Y equal to under root my upon mx. Okay, here rate of from Graham's law of diffusion, rate of diffusion of X gas upon rate of diffusion of Y gas equal to under root my upon mx, molar mass of Y upon molar mass of X. Okay, here we know that rate of diffusion is directly proportional to the volume. Here time to diffuse is same. Time to diffuse here time to diffuse is same. Then here volume of diffusion of gas X upon volume of diffusion of Y gas equal to under root molar mass of Y upon molar mass of X, okay. Here volume equal to cross sectional area into distance. Here cross sectional area is A into here distance is D upon volume. Here this is the D, that will be 24 minus D. Here cross sectional area A into 24 minus D equal to under root molar mass of Y. Here term is a molar mass of Y is given 40 and molar mass of X is given 10. Okay, that will value 2. That will cross sectional area A and A cancel out. D upon 24 minus D equal to 2. Cross multiplication. Here D equal to 48 minus 2D. That will value 3D equal to 48. So D will be D equal to 48 by 3. That will value 16. So D will be here D equal to 16. So answer will be option third, option C. Here answer is option C. Okay, thank you.
Hello and welcome. The question is math gases under specified condition in column 1 with their properties or laws in column 2. Hydrogen gas pressure is this, temperature is this, compressibility factor is not equals to 1. this is this is greater than 1. So P is this answer. Hydrogen, when pressure is 0 and temperature is this. So hydrogen gas at this temperature, your compressibility factor PV is equals to nRT. So Z, PV by nRT is Z, which will become 1. So at this condition your value is 1 in case of hydrogen. What about CO2 at 1 atm and 273 Kelvin? At CO2 1 atm and this real gas of CO2, so your compressibility factor is less than 1, so which is not equals to 1. If this is less than 1, so what will be the value? The value will be PVM is equals to, one second, this PV minus of P and B is equals to nRT. No, this is not the case. In case of CO2, Z is less than 1, then PA Vm square and Vm minus of B is equals to RT. Attractive forces dominate. B tends to 0. So yeah, attractive forces dominate and compressibility factor is not 1 because this is less than 1. What about real gas with very large molar volume? So real gas with very large molar volume, we cannot neglect the B, but we can neglect A. So again in this case P is also not equals to 1. No, in this case P is 1. That is why, yeah, compressibility factor is 1. So in this case compressibility factor is not 1. It is either greater than or less than. But in case of this, your compressibility factor is less because molar volume is high. So B can be neglected. B plus Vm is equals to RT. So this is PV M. So this Z is 1 minus of A Vm. So this is attractive forces dominated. So P is this, PQ. PQ is there. So these are the correct options.
Hello everyone, so in this question it is given the absolute temperature of an ideal gas is dash 2/10, then the average kinetic energy of a gas molecule. So basically when we talk about an ideal gas, we have an ideal gas equation which is given as PV equals to nRT. So this is the ideal gas equation. So when we're dealing with the ideal gas have a kinetic energy. So this kinetic energy, that is EK, is given as 3/2 times of N times RT. So basically if we write this for 1 mole of a gas, then it is equals to 3/2 times of RT. So this is the kinetic energy of a gas. So EK is equals to 1.5 times R times T. You can see here that EK is always greater than T because it is 1.5 times the temperature, initial temperature that will be given. So that's why EK value, that is kinetic energy value, is always greater than T, always greater than the temperature. Now in our statement, the value which should be assigned here, that is absolute temperature. So absolute temperature is always less than the kinetic energy. So that's why here the statement comes as a less. That is, the answer is less. The temperature, that is absolute temperature, is always less than the average kinetic energy of a gas molecule. So I hope you get the answer.
The question is 8 grams each of oxygen and hydrogen at 27 degrees Celsius will have the total kinetic energy in the ratio of. So this total kinetic energy, it is given as 3/2 nRT, where N is the number of moles of gas, R is the gas constant, and T is the temperature. So we have to calculate the ratio of the total kinetic energy of oxygen to the total kinetic energy of hydrogen. So it will be equal to 3/2 the number of moles of oxygen into RT divided by 3/2 into the number of moles of hydrogen into RT. So from here, this 3/2 will get cancelled out, RT with RT. So it will be equal to the number of moles of O2 by the number of moles of H2. So number of moles, they are given as the mass of gas in grams divided by its molar mass. So the number of moles of O2 will be equal to its mass in grams. It is given 8 grams divided by its molar mass. Its molar mass, it is 32. So it will be equal to 1/4. And the number of moles of hydrogen, it will be its mass in grams, which is 8, and its molar mass, which is 2. So it will be 4. So now if we put these values here, so it will be 1/4 divided by 4. So it will be 1/16. So the ratio will be 1/16.